Hello ladies and gentlemen, today we're going to talk about all that you need to include on an installation drawing for your mechanical crew. Throughout the video you can look for the little box that tells you whether the dimension needs to be on top view drawings or elevation view as well. If it's highlighted blue, it only applies to ceiling hung conveyor. For example, the dimension here is between ceiling hangers, so we can plot that on the concrete floor. And any dimension that applies to all conveyor, ceiling or floor supported, will be highlighted green. For example, here we have support height, so you need that dimension whether you're ceiling hanging or floor supported. For every conveyor, you're going to need at least 3 dimensions, 2 for placement in the building and a third for elevation. First, we'll take a look at center lines. Here we have 4 conveyors, so we have 4 center lines pulled from the datum. Sometimes you'll remember to give the position of the spurs off of this sorter, but then you'll forget that we also need the center line of these down lanes. Same deal here for one stick of conveyor after a curve. You just can't forget about this one stick needing a center line while pulling dimensions for the rest of the main system. So the center lines you've pulled allow the installer to run a chalk line on the floor. The next placement dimension you need to pull is the end, which will be down here. I heard somebody on a site calling this an endo. I thought that was perfect to avoid confusion about what you're talking about, so now we call them that. And don't forget to pull an endo for each end of the conveyor. You don't know which end your installer will want to start from, what's easiest on site. So provide both endos and the center line for placement in the building. Up to this point, we've talked about conveyor that's square with the building. But for anything that isn't square, you'll actually have to provide 2 points. One at the infeed and one at the discharge end. This will allow us to pull a center chalk line and will give the position of our endos at the same time. So you're actually providing an X and Y dimension to each of these points. Here's your X, here's your Y. If you have a pop-up diverter that has to be installed, dimension from the center of the diverter to a nearby bed seam so your installer knows where they have to pop out rollers and install that diverter. Don't try to dimension from one end or the other on the diverter because it doesn't have a definite end point like a stick of conveyor does. Now for the spur that the diverter is feeding onto, I prefer that you provide a distance from the center of the spur to a nearby bed seam. What I normally see people pull a dimension from here on these spurs is this corner of the bed frame, but that CAD block you have is not consistent with reality. Now if you have floor supported conveyor that inclines up and then leads on to a mezzanine, we need the mezzanine height so that we can compare it with what's in reality, because if that mezzanine is different from what your drawing says, that means our incline going up to the mezzanine is going to change pitch so that we can still meet that 30-inch top of roller on top of the mezzanine. For inclines, we need the infeed and discharge top of roller, and some people stop there, but it's best practice to provide dimensions for the actual supports on inclines. It doesn't take any time to do this in CAD, and it saves us installers calculating time in the field. These dimensions won't be perfect, but they'll get us started. They're going to be close. Here's the first dimension that applies only to ceiling hung conveyor, and here we're showing you need to pull an X and Y dimension to the outside hanger on the curve. Of course, you don't have to pull that on the inside, just like floor supported. It won't get a support there. Now for all the straight runs that are ceiling hung, you'll provide a dimension from hanger to hanger and from hanger to a column or datum. For example, here you see the first dimension is pulled from the column 5'11" over to the first hanger, and then thereafter from hanger to hanger, 10 foot between, 8 foot, then the other direction from the column to the first hanger, 8 inches, then from hanger to hanger, 7'6", 10 foot. And this allows us to plot where the hangers will be on the floor. Then we'll plumb up a laser. Here's the side view of what we just talked about. those dimensions you're providing between the hangers are horizontal dimensions. That's different than your bed length, which is 10 foot. This 9.6 allows us, again, to plot that on the floor and then plumb up our lasers into the joists. Provide the length of each bed. This gives us an idea of what we're looking for when we're sorting through the mile of conveyor that's still palletized. Also give the overall length of the entire FO, like here 65 foot 2, 19 foot 4. This gives us a quick mental picture of how much room we're taking up and helps us during the layout process. I think some people wonder, or there's some confusion about what dimension we want for ceiling hung conveyor, and it's no different from floor supported conveyor. We want bottom of frame to the floor. So for example, here you have the support height, which is bottom frame to floor, and then here you start ceiling hung and it's still over the mez, so you go from top of deck to the bottom of frame, and then once you get out here away from the mezzanine, it's bottom of frame to the concrete slab. It makes it easy for us to run a measuring laser or measuring tape down while we're installing all of this. And then of course afterward we go through with the rotary laser and make everything perfectly level. Also for ceiling hung we need the dimension from bottom of steel web joist to the concrete slab. Here it's 33 foot 6, and if it's a pitched roof we'd need a range. Let's say it goes from 31 foot up to 33 foot 6. That gives us what we need to fabricate our ceiling hangers. Now we're getting into some labels, so this should go faster. Label your compressor and any pertinent information, and of course a rough idea of where the pipe will be if we're installing your pneumatic system. Label locations for your air drops. This is something I rarely see someone provide on a drawing, but if you do, you're setting yourself apart from the rest out there. Pressure settings for belt dampeners, pneumatic take-ups, accumulation conveyor. It's just nice working with integrators that take the time to include all the details. We don't have to worry about calling manufacturer. If you have different width of poly tiers throughout your system, just go through and label the dimensions on all of them. This is a simple situation right here, but if you have a system with 10 different width supports, it gets really confusing, and as you can imagine, if it's not labeled, we put it in the wrong spot. We don't like doing it twice. Label gates. Of course you can tell this is a gate from above right here, but sometimes it's not so easy to tell. Label gravity conveyor. This is helpful so that we don't end up looking all over hell's half acre for a stick of E24 when it's actually a stick of gravity. Of course, label your control panel and other equipment. You already know that. And I already mentioned to provide pressure settings so we can set the FRLs. I had somebody say, what's a FRL? Filter regulator lubricator. Another silly one, label stepovers. If you have pop-up stops that have to be installed, label and dimension it. And just like a diverter, label from a nearby bed seam over to where we have to pop out a roller and install that pop-up stop. Alright, this might be getting a little nitty-gritty. Label end stops. Who made this outline for the video? Label walk paths or drive paths, so we'll put the knee braces facing the other direction or keep them to a minimum. If it's a part of the mechanical scope, label photo eyes and e-stop pull cords that need to be mounted. And if you have conveyor of different widths meeting up to each other, label whether they're aligned on one side or centered on each other. For example, here you have some E24 running onto some slider bed, and that 36-inch is aligned to the left side with that 30-inch wide. And then down at this end, you see the two conveyors are centered on each other. Dimension or label the overall width of each of your conveyors. Label mark and FO number for each conveyor. And you could just put all of them in one box, the model, FO, mark number, and the overall width. Provide flow arrows. You'd actually be surprised at how often these are left off drawings. Label strongbacks, and remember, strongbacks are not that little angle iron bracket that you can sometimes use underneath a seam to move a support down the line a little bit. A strongback looks like a bed frame without rollers. I'm going to take a little bird walk here like David Kelly with idea, I would say. So here's some high troll trash conveyor. Here you got regular bed section, here's a drive, and then back here you see right here at the seam of these two beds you have a strong back, which just looks like a bed frame in place of a support. So now you got 20 foot between supports and you can have forklift traffic. If there are multiple types of guardrail throughout the system, label it, like here, 2-tier adjustable channel. Here's a single tier, some channel guardrail here. Usually the guardrail is uniform throughout the system, so this is a rare circumstance. And this looks like an insane situation, but I've been on a job site where it was almost as bad as this. Like, what, 1, 2, 3, 4 different types of guardrail. If it's this confusing, you should probably provide a little drawing. This is just to give you an example. Like I said, I've been on a job site where it was like a box of chocolates, the variety of guardrail they had on there. For adjustable channel, just label how far it is above the top of roller. So it would look like this. Obviously, you don't have to provide this. We would know this from the description in the past slide. But so here you got the top tier, 12-inch above, and then bottom tier, 4-inch above roller. And that's the center of rail. And if you're installing over some obstacle or let's say an office building within the warehouse, provide a dimension for, let's say, the height. That way, while we're installing an incline or something over top of it, we know we're not going to hit it and we can plan ahead if we have to change the pitch or something. Whenever we're tying into something existing, provide validation dimensions. For example, here, this existing blue conveyor, here's a center line and endo. So we can double check that it's where our drawing says it is before we start installing this line halfway across the building so that when we get up to it, we actually meet it. Here's an example of some pick lines. You may want to put in some validation dimensions for this racking so we can double check that at the beginning of the job and make sure all the pick lines will be pretty much right in the center of the rack rows. Another example for validation dimensions. Here, this conveyor is going to come out here off a mezzanine and then install on top of some existing racking. So if you provide dimensions for that racking, we can validate that it's in the right spot. That way, when we're installing this whole conveyor system, we know whether or not we have to shift the whole system so that we fall on top of that rack. Here's a situation that you don't run into every day. Right here, you have a wall. On the right side is an existing building, and on the left side, you have a brand new building. And if we zoom in right here, and if you give validation dimensions, we can make sure the column layout on this side of the building and on this side of the building is where your drawing says it is. Provide distance between columns, east to west and north to south, and some validation dimensions for anything you're going to be installing super close to. So the corner of this building, we know it's going to be super close to this curve. We can double check that the room is where your drawing says it is.